So your first test will be in the middle of February, just to put it into context. And I'll be sure to announce that date in our first class next week on Tuesday, so you'll be sure of when that is. You can go to the calendar in ALEKS, but I'm likely to move that out a little bit, like by one class period, because due to the way registration was conducted this semester, and also because we had the first purge didn't occur until Monday of the first week of class, where they purged students for non-payment, and it caused, I just think I wanted to be fair to students and make sure that they had ample time to work on the beginning material in the class, even if they join the class late in the week. Okay, I see somebody trying to get in, so let me let them in. Okay, so let's get started and look at solving rational equations. There are a couple topics that we are going to do about complex numbers, and we will use those topics to warm up. So here, hopefully you can all see the screen, and let me just double check that I put on the recording, and I did. Okay, so I want to look at this. Objective 3 is really about rational equations. In other words, solving equations that have a variable or one or more variables in the denominator. But we're also going to look at complex numbers, as we are going to use them in more advanced topics in the next objective. So I want to look at the introductory topics for complex numbers as well. So let's look at this. So first of all, let's talk about complex numbers. Complex numbers came about because mathematicians discovered that the real number system isn't big enough for their needs. In particular, what happens if a mathematician wants to take the square root of a negative number? So they discovered that they needed something to stand for the square root of -1. And they decided that they were going to use I. I is called the imaginary unit. I is not a number, it's just the imaginary unit, called the imaginary unit. I do want to say that all real numbers are complex numbers, but not all complex numbers are real numbers. So the complex number system is much more vast than the real number system. There's way more numbers in the complex number system. When we graph in the complex number system, it's much more involved than graphing in the real number system. All real numbers are complex numbers, though. So I would encourage you to copy down what's in these red boxes, what's inside these red boxes here, if you will. Copy these down. These are good formulas to put in your notebooks. As is what's in this red box. We're going to also be talking about perimeter and area today. So I would like you to copy down what's in both those red boxes. The more senses you use in your learning, the more likely you are going to do better in this course. You're certainly not going to do worse. You're more likely to do better. From what I have seen in class when I taught on campus last, I saw the students that kept nice, organized notebooks did very well in the class. So I will give you a couple more minutes to copy down what's in all three of those red boxes. or red rectangles. I'll give you a couple more minutes until 12:08. That way you can have all of your important information in one place in your notebook. Like you can use a tab for the formulas, let's say, or important information. Like you might want to label, for instance, one tab, formulas and important information for test 1. Okay, anybody need more time to copy what's down in those 3 red boxes? You're not going to see it like that in ALEKS, where it's together like that. And I don't think you'll see it written out like this in ALEKS. I haven't seen it in ALEKS like this. So we've got information about I, the imaginary unit that we use for complex numbers. We're going to talk about perimeter and area. First, we're going to talk about complex numbers, so we'll come back and revisit this box in a little bit. So let's talk about complex numbers. They are the numbers that if you take the square root of them, they have a negative inside the square root. So remember, last time on, let's see, Tuesday, we talked about how a negative is a -1. So that negative really represents -1. And the reason I say that is because if we go back here, when we have the square root of -1, it's this imaginary unit I. So I copied that down here, that formula, if you will, or that important piece of information. Square root of -1 is I. There is that icon, a special I icon in ALEKS. You may not be able to see it too well on this document, but it's right there. And so what we want to simplify, we want to write this square root in terms of I. That's the direction. Simplify your answer as much as possible. So it's important to understand what the directions give you so you do not forget to do something. So it's important to read those directions and not just assume that you know what they're asking for. So let's take a look. I copied the square root of -8 down here. Since a negative sign is exactly the same as -1, you can take out that negative sign and replace it with -1. 8, we can break down into a factor tree using a factor tree. 8 is an even number, so we can divide it, take the 8 and divide it by 2 to get 4. 4 is a perfect square. We can take the square root of 4 easily. It's 2. So you can break it down to here, or you could go further and break this 4 down into 2 times 2 if you need to and want to. So it's up to you how far you go with that factor tree. So what does that mean? We can rewrite -8 has that negative, we can rewrite as -1, and the 8, the roots of this factor tree are 4 and 2. 4 times 2. The square root of a product, all of these are being multiplied together, is the product of the square roots. That means we can take the square root of the first factor times the square root of the second factor times the square root of the third factor if it's applicable. So the square root of the first factor here, the square root of -1, is I. So I wrote down an I here. The square root of 4 is 2. So I put a 2 outside. And then the square root of 2, we can't break 2 down anymore. It's a prime number. Its only factors are 1 and itself, which is 2. So we leave it inside the square root. And typically, what we do is we write our numbers like this, the number, the real number first, and then the imaginary unit. So 2i square root of 2. 2i square root of 2 is the answer. Any questions on this first topic of the day?
No.
Good. Thank you for the feedback. I really, really like the feedback. No question is too small. I never think about student names and who asks me questions. And, I don't look at students that way. I know we all come from such different backgrounds and, and had different, that means different high schools, had different teachers and so forth. And so I want to be able to answer all your questions. So at any time, feel free to unmute your mic and speak out. I think our class is small enough. We've got 11 in our class. So I think we're not going to have too much interference with the mics. I think we're good. So let's go on and look at a couple more complex problems. So this problem is the same exact topic that we just looked at, but it's a little more challenging. So let's take a look at this one. Write in terms of I, simplify your answer as much as possible. Negative outside, square root of -96 inside. So let's copy down that negative sign out front. Put a big square root sign because we're going to make a factor tree. So 96, well, first of all, inside, let's replace this negative with a -1. And then let's take this 96 and make a factor tree out of it. We've done factor trees before in the class, so that makes a lot of sense. So this 96 is even. So you can take 96 divided by 2, you will get 48. 48 is even. You can take 48 and divide it by 2 and get 24. 24 is even, so you can take 24 and divide it by 2 and get 12. 12 is even, so you can divide 12 by 2 and get 6. 6 is even, so you can divide 6 by 2 and get 3. So what do we have? We've got 2, 1, we've got a 2 here. So we have 1, 2, 2 of those 2s, 3 of those 2s, 4 of those 2s, 5 of those 2s. 1, 2, 3, 4, 5 inside, and this lonely 3. So we're talking about a square root and not a cube root because we've got in this V down, right in the V here, we don't have anything written. And when we don't have anything written, it's assumed to be a square root. We have looked at cube roots before, and we'll do more of cube roots later in the class, later in the semester. And so what we're assuming is that we have a 2 in the V. So that means we have to have 2 of the same factor before we can take it out as a single factor. So I paired up these 2 2s, paired up these 2 2s. This doesn't have a buddy. There's only 1 of 2 left, so we have to leave that 2 inside the square root. And since we only have 1 3, we have to leave that inside the square root. So let's copy down this negative sign. Square root of a -1 is I. So I wrote down this I. For this pair of 2's, for every 2 of the same, we can take it out as a single one. So we've got 2 2's. That means we can take it out as a single 2. So that's this 2. Here's another pair of 2's. So we can take that out as a single 2. Here's that 2. And what do we have left inside the square root? This one out, this one out, this one out. We have 2 times 3 left, which is 6. So we can just write that as square root of 2 times 3, which is the square root of 6. And all we have to do is clean up our answer. That would be negative. We usually write the real number first, 2 times 2, which is 4. And then we have this I, and then we have the square root of 6. So that is our answer. So you want to use the I icon in ALEKS to enter such numbers. Any questions on the second question in the same topic? I like to occasionally do 2 questions in a topic so you can see how the complexity of it, how one problem differs from another, and what to expect when you get into the software. Any questions?
Did you replace the -1 with the I for the answer?
Square root of a -1 is I.
Okay.
So you want to make sure square root of -1 is I. If you haven't had a chance to jot it down, I would encourage you to jot both of these down right now, since we're talking about I. Okay. So why don't you, so that's just good to jot that down. So square root of -1 is I. So right when we go back here, we have a square root of -1 here, square root, and -1. Took that out, replace that by this I right here. Does that make sense?
So you replace the -1 with the -I?
We're replacing square root of -1 with I. Square root of -1 with I. Does that make sense?
And the negative came from the negative square root?
So let me write this out for you so there's no confusion. So what we really have here, and I'll have to go down a little bit. If I look at this, we really have I, okay? And we really have, if I break this down into square roots, we really have square root of -1. And then we've got square root of the rest. We could break that all down too, but I don't really want to. It would take a lot of time to write it out, but I can write it. We've got our pairs of 2s. We've got another pair of 2s. So we've got this pair of 2s. I think I want to just talk about that. We've got another pair of 2s. We could break do square root of 1 times square root of, well, first of all, the negative. Then we could do square root of -1, square root of 2, 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 square root of 3, if it would suit us. But it's better to leave the numbers inside to see where they pair up, so you can take 2 of them out as a single one. But really, that's what we could go all the way down to that level, but I don't think we need to. I think the concern is with that I. So now this is really square. This -1's inside the square root, so it really has to have a square root on it, like this. Square root of -1. Does that make sense?
Yes, thank you.
You're welcome. Any other questions, comments? I want to make sure you're knowing how to use what represents I and see it in practice. So let's go on to a different topic involving complex numbers, multiplying complex numbers. So we're in this one, what we have here is we want to take -I, and it's on the outside. There's no square roots involved in this problem. So let me just copy that down here for you. We've got -I, parenthesis, -3 plus 5I. And let me just make sure that I'm recording. Now we've got people in the lobby. See if that works. Okay. So I'm going to make a special request. If you are going to need to be admitted to the class, in other words, if you go into Canvas and use the link in Canvas, you go to the home page, you scroll down and click on that link. You probably can get straight in unless you're outside of the organization. So if you need to be admitted to the class by me, please make every effort to be on time so I don't need to interrupt class. I do understand that occasionally we all have doctor's appointments that go over or something like that, but what I'm trying to do is minimize the number of times that I have to interrupt class to let people in to the class. So I think that would give us more time for all of us to understand what is going on. Okay. And I just mean that for all of you. So if you're in our considered to be in our organization, if you go to the Canvas homepage, scroll down, you can click on that link and you can get straight in. You should be able to get straight into the class without having me admit you. If you're outside of the organization, that's a different issue. However, if you're outside of the organization, try to have me let you in before class starts. So getting back to this problem, every real number is complex, but every complex number is not real. In other words, there's way more complex numbers. Well, since every real number is complex, we can do our problems like we're used to doing them, keeping in mind that the square root of -1 is I and so forth. So what we have here is a number, -I. Actually, we could say that we've got two numbers there, but we've got -I here times addition. So we have multiplication over addition. So we can distribute that -I through. So we have -I times -3. A negative times a negative is a positive. And then we have I times 3. We usually write the I last. That will give us 3I. So we're just distributing here. Multiplication over addition. We're just using the distributive property. So the next one, -I times 5I. So we have a negative times a positive, which is negative. We have an I here. Let's write that down. 5 here, write that down, and an I. So let's clean this up as much as possible. So 3I, just copy down the minus sign, copy this 5 down. We have I times I. So let's write that as I squared. So if we take a look at the square root of -1 being I for a moment. So I is equal to the square root of -1. What happens when I square both sides? So now we want to square both sides. So we're starting with that. Let me get a different color. How about blue? Let me make sure I've got the blue going there. So if we want to square this side, software is a bit quirky, forgive me, but it's free and it works. So I'm going to square both sides. What do we get? On this side, we get I squared. On this side, when you take a square root and square it, they're opposite of each other, so we get just what's inside this square root, which is -1. And that was our other formula involving I. So this is the definite formula that you want to know, that we looked at the very beginning of class. So right here, this I squared, I circled it and replaced that I squared by what it's equal to, which is -1, which is a real number. So now we have 3I, copied that down, minus a -1. And actually, let's be really, really clear about this. We need to be really, really clear about this. And I didn't read this correctly. Let me read it again. 3I minus 5 times a -1. And I say this because this is a common error. So this is, again, is -5 times -1. When you cross this out, you want to put parentheses around this -1. If you do not put parentheses around this -1, it's going to look like -5 minus 1. But that's not what's going on here. It is actually -5. There's a times here. There's an understood multiplication symbol right there. So it's actually -5 times -1. It's -5 times -1. So negative times negative is positive. 5 times 1 is 5. So when you write and replace I squared by -1, make sure you put parentheses around it to remind yourself that it's multiplication and not subtraction. Unless you're 100% sure you're going to remember. So we have -5 times, we've got -5 times -1, which is +5 here. And we usually always write the I term last, so that's why I wrote it the other way. Addition is commutative, so we can add in any order. So we usually write this as 5 plus 3I, where the I term is last. That's the standard form for complex numbers. And we do use complex numbers later in this course, and you want to make sure you're writing them that way. If you write them with the I term last, it might be a bit confusing for you because we're going to use complex numbers when we get to polynomial theory. So the answer is 5 plus 3I. Anybody have any questions on that? Let's look at it and see if we want to look at another one. Yeah, let's look at another one. This is the same topic, different question. So in the problem we just did, we needed to distribute that one number through. But here, when we multiply, we've got 2 terms here times 2 terms here. We want to use FOIL, the FOIL method to do this. So let's take a look. -1 times -5. Negative times negative is positive. 1 times 5 is 5. So F is the first two. -1, the negative, it's the first one in each factor. -1 times -5. That's +5. The O is outer. It's the -1 and the 2I. So we have a negative times a positive, which is negative. We've got a 1 here and a 2I here. We multiply 1 and 2I together, we get 2I. You already took care of the sign. Inner are these two in the inside. So we've got a positive times a negative, which is a negative. We've got 5i times 5. 5 times 5 is 25. And then we have this lonely I here. And then the last two is this term times this term. So that's 5i times 2i. It's positive times positive, so we get a positive. 5 times 2 is 10. And then I times I is I squared. Crossed out the I squared. I squared is equal to -1, but it's participating in multiplication here. There's an understood multiplication sign here. So I'm going to write this as parentheses -1 to remind myself that it's participating in multiplication. So let's go ahead and see what this is equal to. So we have 10 times -1. That is a -10. So let's work with our constants first. So we have 5 plus a -10. That's -5. These are like terms because they have the same imaginary unit in them. We consider them to be like terms. They have the same imaginary unit to the same exponent, if you will. So they're considered to be like terms. We have -2 of them here, -25 of them. So that's a total of -27i. So the answer is -5 minus 27i. Any questions on this particular topic? I think we're ready to talk about perimeter and area of a rectangle. So let's go back up here. I'll give you a minute or so to jot down what's in this red rectangle. It might help you better understand what I'm talking about in the class, but also these are definitely, there's a couple of formulas in here that you're definitely going to want to know for the test. The perimeter formula, the perimeter of a rectangle formula, and the area of a rectangular formula. Give you a minute or two to make sure you've got that copied down. Perimeter is the distance to walk around a rectangle. It's the outside border of the rectangle. It's how much fencing would you need if you wanted to fence in a grassy area for your cattle. How much fencing would you need? That's perimeter. Area is the amount of land inside the fencing, if you will. So let me know, does anybody need more time to copy down what's in that box?
Give me 1 second.
Sure.
I have a
Absolutely.
question.
Absolutely.
Do we have to foil every time there's the parentheses for the eyes?
If there's two terms in each. The only time you can FOIL is if you have two terms times two terms.
Okay. Thank you.
So you're welcome. And that goes for any foiling that we've done so far in the class, or any foiling that we will do. The only time you can FOIL is if you've got two terms in one factor and two terms in the next factor. And you can only do it if you have two factors.
Okay.
Everybody good with, does anybody need more time to copy this down?
Miss Bear, I had a question.
Sure.
Do you think that it's important to have like two separate notebooks for like when we're doing our work on ALEC and when you're discussing different problems here during class?
I guess it all depends on how big your notebook is.
Because I mean, I have a big notebook, but I feel like I'm having a hard time like keeping it organized because I'm, working on certain stuff through Alec, and then whenever I get to class, we might be discussing something else, and then I'm starting somewhere new in my
Oh,
note.
I see exactly what you're saying, and that is true. Because what I don't want to do is, for example, there's an objective due tonight,
Mm-hmm.
review part 2. I wanted you to have the opportunity, say during office hours after class, to ask me questions about that particular objective, so that you could get your questions answered, so you could finish up that objective.
Right.
So I totally understand what you're saying, and you bring up a really, really good point there. And what I would maybe suggest that you do is you label you might want 2 notebooks, but just label them or tab them or somehow by objective name.
Okay.
And the objective names this is a great discussion. So I really want to let's go into Alex for a second.
Like, for example, right now we were working on multiplying complex numbers. Like, would that be
I would do it by objective, really. So let me go into Alex. And so I can take a look here and show you what maybe you can ask some questions about that. And this is just, different strokes for different folks. This may not work for all students. I mean, you want to just a suggestion here. And I want to look in Alex and see here. So and we're the Tuesday, Thursday class. If you are not yet in Alex, you definitely want to get into Alex. I think there may be a student. I think everybody's in this class, it looks like. Okay, so what I want to do is I want to go to the student view, and I want to look at today's objective. So and I'll have to go somewhere else to get it, because it's review part 2 is due today, 11:59 p.m. That's what we covered on Tuesday. And then this one is due on Sunday. And if you need help from me to finish up that objective on Sunday, I'm more than willing to meet with you Sunday afternoon, Sunday early evening. So let me know. So I want to click on this, and I'm going to go into, let me see. Let me see if I can do this. Okay. So this one is rational equations. That's what we're talking about today. And what I think you should do is label both of your notebooks, what we do in class and what you do in Alex, by whatever topic name we're talking about, if that makes sense. And no, let me be clear, because I misspoke. By whatever objective we're talking about. So our first objective was review part 1. Our second objective was review part 2. Our third objective is rational equations.
okay? Makes sense. Thank you.
You're welcome. It's a very good question. That's what's office hours are for tips too. But if you have a question during class, I'm more than willing to ask it, because I think it probably benefited possibly some of the other students in the class. Okay, well, let's go back and talk about perimeter. So in this topic, this is a topic in the objective rational equations. Sometimes I have to put topics in that I'm really not including in that objective title, because it's too long. And I don't want to do that. Some topics really don't have a good place to go, and they're not enough of them to make an entire objective out of. So we're going to look at perimeter and area. So in this particular topic, you could either be asked to find the perimeter or to find the area. So we're going to take a look at one of each. So I did cross a few things out because I wanted the presentation to be really hunky-dory here. So what's crossed out in red, we want to ignore. So what do we know here? The length of a rectangle is twice its width. If the area of the rectangle is 72 inches squared, find its perimeter. First thing, I wrote down the formulas. Here's the perimeter formula. Here's the area formula. Drew a rectangle. Labeled labeled opposite sides with the same variable. So in this case, I labeled this side with L for length and this side L for length. The other sides I labeled with W for width. And that's staying true to how I wrote the formulas. So let's read the problem. The length of a rectangle is twice the width. So this length down here, we can represent, in other words, this length is equal to twice the width, which is 2W. We can write twice the width as 2 times W. So I put that there right underneath the length to indicate to me that that's another way I can look at the length, because length is equal to 2W. So our goal is to find the perimeter. So what can we do? If the area, so we use this, we already use this. The length of a rectangle is twice its width by putting in the 2W right here. The next piece of information we have, if the area of the rectangle is 72 inches squared. So we know the area is 72 inches squared. So I copied down the area formula here so we could see it right close by. And the area is 72 inches squared. So I took out the A representing the area and put in 72. Now area equals length times width. We could use the L, leave the L, however, we're trying to get this down in terms of one variable. So it's not going to hurt to take this 2W and put it in for the length, because that's an equivalent way of representing the length. So we're going to take out this L and put in the 2W here. And what does that give us? That gives us 72 equals L, but we're going to put in 2W for that L. So that gives us 2W right here, 2W times this W. And how can we write it? 72 just gets copied down, equals 2. We've got 2 of the W's. So we can write that as W squared. That means 2, that's a mathematician's way of representing W times W. Then this 2 means we have 2 W's multiplied together. Exponents are mathematician's way of representing repeated multiplication. Now what can we do? Well, see what else. I noticed that this is an even number. 2 is an even number. Let's divide both sides by 2. 72 divided by 2 is 36. 2 divided by 2 is 1 times w squared is just w squared. How do we do, what's the opposite of squaring? What process is the opposite of squaring? It is square rooting. What's the square root of 36? What's the square root of 36?
6.
6. So W
6.
equals 6. So our width, we now just found it to be 6. Now this length here, so our width is 6. This length here is 2W. So length equals 2W. Length equals 2W. So that's equal to 2. We know what the width is. This W is just 6. So we get 2 times 6 here, and that equals 12. So we now know what the width is of the rectangle and what the length is of the rectangle. The width is 6, the length is 12. I didn't want to clutter up the diagram too much and have it be confusing. Now, lastly, what does the last statement say? Find its perimeter. Well, perimeter is 2L plus 2W. So I just copied that down here. Perimeter is 2L plus 2W. So 2L. L is 12. So I took off the L, put in the 12. Plus 2. Copy down the 2. W is 6. So I took out the W, put in the 6. Just did this calculation. 2 times 12, 24. Plus 2 times 6, 12. When we add 24 and 12, we get 36. 36 is the perimeter. 36 inches is the perimeter. Any questions on this? So if you approach it that way, it really isn't too bad. I think that's about as little as we can get away with there. Any questions on finding the perimeter here before we do a finding area problem?
Wait, where did you get the 2WW from?
The 2WW from? Okay.
Yes.
So let's take a look. 72 equals L times W. The area of a rectangle is 72 inches. That means the area is length times width equals 72. So length times width equals 72. Are you okay with the length times the width being 72?
Yes.
Okay. Now, let's look back up here. We were told at the very start of the problem that the length is twice its width. So this L represents length. Twice the width means 2 times W.
No.
So we're told that the length is twice the width. So another way to represent length, an equivalent way to represent length is 2W. Does that make sense?
Yes.
Okay. So down here, 72 is L times W. So for the L, instead of putting an L, well, actually took out the L and put 2W in its place because these two are equal. So we get the 2W here now.
So 2W and L are equal to each other?
Yes, yes. Because of this word is. The length of a rectangle is. That means equal. The word is means equal. So the length of a rectangle is twice its width. That means the length of a rectangle is the same as twice its width. Does that make sense?
Yes.
Okay. Any other questions on this particular problem? So let's go on And instead of finding its perimeter this time, let's find the area of a rectangle. And we're really going to go about it the same way, read each statement, see what we can do with that statement, and so forth. The length of a rectangle is 4 times its width. So in this case, the length is 4W. If the perimeter of the rectangle is 60 inches, find its area. So again, I wrote down the two formulas here, the perimeter and the area formula. Let's see here. Well, let's just look at this problem. First of all, the length of a rectangle is 4 times its width. I think what I did is I crossed out what I didn't mean to cross out. So let me just kind of correct this up a little bit here, and it won't take long. So we don't want to look at these 6s. This is not what you're going to start with. This is not what you're going to start with here. I want to do it from the very, very start so you can see what's going on with no confusion. I should have left the W's in. So we want W and W. So you want to start off just like you did in the last problem. You want to start off with just a rectangle with two opposite sides being labeled with L and the other two opposite sides being labeled with W. And then go from there. Just starting it out exactly like we did the last problem. Now we want to go and read the statements at the top. The length of a rectangle is 4 times its width. That means the length equals 4 times its width. That's 4W. So we can represent the length. The length is equal to 4 times W. So that's why I put a 4W here and here. The truth is you just need it down here or in one place. So we know that. If the perimeter of the rectangle is 60 inches, so perimeter is equal to 2L plus 2W. But we are told that the perimeter is 60 inches. So I took out the P, put in 60. Equals 2L plus 2W. Just copy those down. However, by putting this 4W right next to L like this reminds us that those two are equal, that the length is 4W. So we can take this 4W and put it in for this L, for the length here. And what do we get? When we do this, we get 60 still. 2 comes down. We put in 4W for the length. And then we add on this 2W. Next step, copy down the 60. 2 times 4 is 8, so we have 8W plus this 2W. Copy down the 60 equals. These are like terms, so we can combine them by taking 8 and adding it to 2, which gives us 10, and then a single W after it, 10W. And now what can we do? We can take and find the width. What do we need to do to find the width? Divide both sides by 10 to find that width. So let's divide both sides by 10. So we have 60 divided by 10. And on this side, we're also going to divide it by 10. And what do we get? 10 divided by 10 is 1, and 1 times W is W, so we're just left with a W on that side. And on this side, 60 divided by 10 is 6. So I turned it around and wrote it with the W first, which we can do. W equals 6 when we do this division. So the width is 6. Any questions on getting that the width is 6? So this turns out to be W equals 6. Just to be really clear, W equals 6. Well, now it's not too bad because all we have to do is use the formula that we haven't used so far, which is the area formula, or to remind us what we need to do, we need to do this last statement right here. Find its area. Area equals length times width. So area equals length times width. So that's equal to, and we might need to find one of these. No. Oh yeah, we need to find the length. How do we find the length? We need to find the length. Let's find the length. So we want to figure out how to find the length. Well, the length is equal to what? The length is equal to 4W. Length is equal to 4W. So the length equals 4W, which is equal to 4 times W. W is 6. So I took out this W, put in 6. 4 times 6 is 24. And now we can find the area. Area, by our formula, is length times width. The length is 24. Let's take out length, take out the L, put in 24. W, on the other hand, is 6. Take out W, put in 6, do the multiplication. 24 times 6 is 144. So 144 is indeed the answer to the problem. Anybody have any questions on this? Yep, it's 144. Just wanted to check. So it's really about, I think if you read those statements and you think about them and try to use these as models of what I did today, I think it's pretty clear what to do. And if you have any questions, I'm more than happy to answer them. I found that presenting it this way works pretty well with my students and has worked well in the past, so that's why I like to present it this way. Any questions? So we are ready. We've been here for an hour now. And before we start talking about solving rational equations, let me come back to all of you. And I want to have our participation time now. And hopefully I can get into the chat here because it's, for some reason, there's this presenting right above here. And I don't, let me see if I can get into the chat. Can one of you click on the chat for me? Is anybody willing to click on the chat? I guess I can stop presenting temporarily. I'll do that. And then we'll go back. I'll try to remember to do that. So this came up yesterday. I had a student in my Alex class yesterday, and he was like, can we form study groups? I need study groups that I think it'll help me learn during this pandemic. And he put his email address in the chat. And there were several other students that followed and also put their email address in the chat as well. And I thought that's a really good idea to use your NWAC email and put your in, and it's going to show your name anyway. So any students that are interested in forming study groups can go about it that way. And we have 11 students in this class, so we don't have a really big class. So what I want to know from you, and you don't have to participate in this, or if you think that you will, please provide, if you are willing to do so, your NWAC email address. Now, I understand that sometimes in some situations, you know, the other day we got one of our accounts got, you know, we had to call the bank about a fraud issue that we got charged something for something that we didn't actually purchase. So, you know, I understand that if you're skeptical about it, that's okay. But I think we're using our NWAC email addresses. I think it should be good, but it's totally up to you. You know, I'm taking all my, every time I purchase something online now, I'm taking my cards out immediately afterwards and so forth, like all of that. So luckily it wasn't a too large of an amount, but I understand that. So what I want you to do is, if you, and you are by no means required to participate in a study group. So Austin, can you go look yours up on your computer in this time? You go into your NWAC Outlook account and look up your email. So the question would be, if you're interested, if you are interested, if you want to participate but don't have your email address handy, or you don't know how to quickly look it up, you're welcome to put your email address in the chat next time we meet. So if you want, this is about Study Buddies. If you want to be involved in this, please provide your NWAC. If you are willing, please provide your NWAC email address. And I'm typing this in right now. Please provide your NWAC email address. I think we should stick to that. And I'm going to type this in the chat just so I have a record of it. And if you don't want to participate, it could be your schedule is so full or whatever, just let me know that you just say, you know, I don't have time or something like that, because I want to make sure I'm giving you credit for participation and I need a reminder to do so. Wow, that's really good. That's really, really good. So I'll give you another minute or two. Before I forget, I'm going to reshare my screen. So I just want to make sure you all get credit for your participation points for today. So I thought we would do that. It worked so well in the last class yesterday, the one I had yesterday, with it's going over the same material as y'all. I thought it would be a good thing to try. And I will look into. I'm going to talk to some of people around the college via email, and I'm going to ask them if they know of a good app to use or something like that. Okay, so I think this is good. Yeah, I understand about don't having the time. That's it. It is a challenge for some of us, but if you do, you know, and you can try, other people may have different times. Maybe that's part of the app. And anyway, I will keep all of that in mind when I write my email to some people I know might have a great answer. So let's get back to what we were talking about. Let's talk But let's now talk about solving rational equations. And I've got to find my document here. I think I put it in the second part here. Let me see if I can locate this document. Yes. So this is a process, and this is something you should probably keep in your notebooks. This is a process, solving rational equations. I wrote up this little process for you. So I would encourage you all to copy this down. So let me just see. There's a couple tips about rational equations, but this process shows right there. This is a solving rational equations process, and rational equations is the name of this objective that we are doing. So I'll give you a couple minutes, 2 or 3 minutes to copy this down. I will also investigate the best place for you all to which software should you use to meet virtually. Now that's up to the individual groups, but I'm going to check with the college and see what they're recommending for that. I know some instructors use Zoom. In the fall, we didn't have any, they were instructors were recommending not to use Zoom, but now we have some licenses. So I want to just double check with the college. And I also want to do this with my online anytime students. So I will check with them. I'm excited. Anybody need more time to copy that down? Don't be shy. I really want to know. I just can't see it. Okay, yeah, that's good. I'm not in a classroom and I can't see, if all of you have put your writing utensils down. And it's nice for you to have this right by your side as we go through these problems anyway, so you can see and refer to it. I printed one off for myself too. So I've got it right by my side. Just let me know when you're done, if you will, please.
I'm done now.
Anybody else need more time? Thank you for letting me know. Okay, so let's get started here with solving rational equations. A rational equation consists of rational expressions. A rational expression is the ratio of two polynomials. So polynomials are nice functions that I think we're used to working with. The difference here is we have a polynomial in the numerator and also likely another different polynomial in the denominator. And we have an equation that may have several different rational expressions in it. So we're going to start with something simple. And in this process that you just copied down, you're not going to use all steps for every single equation, but you want to think about each step and if you need to use it. So for example, in this one, I think this is big enough here. 4 equals 9 minus 3 divided by 8z. There's only the first step of the process is completely factor all denominators, but there's no way to factor the single denominator that we have. We really have a single visible denominator, and there's no way to factor that further. This 4 is really over 1 if you want to, and this 9's over 1, but there's no factoring to be done with those either. There's no factoring the denominators in this case, but we will get to a problem where we are going to do that. More than 1. Next step, find the least common denominator. Well, we really only have one visible denominator, and when you only have one visible denominator, the least common denominator, the smallest denominator you can get away with, is really what that is. In this case, it's 8z, since that's our only visible denominator. The purpose of the LCD is to clear the fractions so that you're only working with an equation in the numerator, if you will. So we're going to take our original equation and multiply both sides by our least common denominator, the smallest denominator we can get away with. And that's important because you don't want to work with cubics or quartics if you don't have to. You'd rather just work with at most, say, a linear or a quadratic. So we're going to multiply both sides by the LCD to clear the fractions. So I just copied over 4, copied over 9 minus 3/8z, and put the LCD in front of each one of those. And we multiply both sides by that. So this is 8 times z times 4. So 8 times 4 is 32 times z equals. This is multiplication. Subtraction's adding a negative, so we really have, we can distribute here. So we take 8z times 9, 8z times 9, and then we have a minus sign. And then we take 8z times 3 over 8z. And what you will notice is now we have an 8z in the numerator and an 8z in the denominator, and we can cancel those, meaning 8z divided by 8z is 1 times 3. 1 times 3 is still 3. That's what allows us to cancel these 8z's. So the next step, number 4, solve that equation. So it's up to you how you want to solve this equation. We've got 72z here. The opposite of adding, subtracting. So let's subtract 72z from both sides. 32 minus 72 gives us negative 40. And in particular, negative 40z. Over here, we're just left with a negative 3. So we want to get z by itself. We've got negative 40 times z. The opposite of multiplication is division. Let's divide both sides by negative 40. And this will give us negative over negative, which is a positive. 40 divided by 40 is 1 times z is just z. Over here, we have negative divided by a negative. That's positive. And we have 3 over 40. Now what we want to do is check in step 5, check all possible solutions in all denominators. If no possible solutions work, then answer is no solution. So what I did here is I just copied down the denominator, the only visible denominator, 8z. I plugged in 3 over 40 here for z, which was what we found, 8 times 3 over 40. What we are concerned with, and you might want to make a note there, we are concerned with division by 0. Division by 0 is undefined. You might want to write that in. Division by 0 is undefined. I'm writing that in my solving rational equations in step 5. Division by 0 is undefined. So my point is this does not equal 0. So when it does not equal 0, then this is an answer. The only time you have to be careful is when you get 0. You have to throw out that solution. You can't ever have division by 0. So the answer is z equals 3 over 40. Any questions on this particular problem? So let's take a look at another one. In this one, we've got 2 denominators, but only one of which has a variable in it. But we're going to have to be careful nonetheless. We want to solve for z. We want to find the LCD, the least common denominator. And I skipped one of the steps. The first step, completely factor all denominators. We will have a place where we need to factor today, but here, this is a lonely z, can't factor it. You could technically factor it into z times 1, but that's not very helpful. And this one is, we can't factor it either unless we're going to write 2 times 1. So we want to find the least common denominator. So here's how we find the least common denominator. We start on the left, we go until we hit the first visible denominator, that is z. We copy that down. I put a z here for the LCD, the least common denominator. We then go and hit the next denominator, and it is 2. And at this point, we just have a z there. If this was z again, we would not have to write another z down, but we'll talk more about that later. This is different. This is 2. We definitely have to write this down. So our least common denominator, and then we're out of denominators, is z times 2, which is 2z. Now, what do we do with that least common denominator? We want to multiply both sides by the LCD to clear the fraction. To clear the fractions, in other words, to get rid of the fractions. So we want to take and multiply this side right here write it like this if you wish. I'm going to multiply everything on both sides by 2z. That's what we really need to do. And that means 2z times 4 plus 2z times 6 divided by z equals 2z times 5 over 2. That's what we need to do. Or you could write it like this, 2z times the left side equals 2z times the right side, whatever you choose. So if we do that, if we do it this way, we want to distribute this 2z through, actually distribute it through on both sides. So 2 times 4 is 8. And then we have a z. And that's a crazy looking z. It's unclear what that is. So we've got 8, got to get those sharp corners there, z, plus 2 times 6. Let's do the numbers first. Plus is right here, so plus 2 times 6, that's 12. And now what happens with the z? We've got a z upstairs and a z downstairs. They cancel, right? Z divided by z is 1. So we don't have to put anything there. And then equals, let's do the numbers first here. 2 times 5, which is 10. And then we also have 2 here. So we have 2 times 5, which is 10. And then we have a 2 here. We have to cancel with this 2 down here. Does everybody see that? This 2 is going to cancel with this 2 down here. And when you're done, if you've done everything right, you shouldn't see any visible denominators.
Is that for every one of these problems? That you shouldn't see a denominator after those?
Yeah, at this step, that's correct. You shouldn't see a denominator. Otherwise, your LCD is incorrect or you've made a mistake. Okay? Does that make sense? Is everybody good with that?
Yes, a little bit.
Okay, so let's keep going. Let's just go from here. I think this might be better. Let's look at it from this side. So let's just look at this part of it on this side. Let's just go from here. Now, what do we want to do? We want to solve for z, obviously, right? So we want to get everything away from this term that involves a z as possible. So let's subtract 12 from both sides. So we'll get 8z here. 12 minus 12 is 0. 8z plus 0 is still 8z. Equals 10 minus 12 is negative 2. Wait, I did something wrong.
So why is the other side
Yes, I know. Let me just figure that out. I'm looking at that to myself as well, okay? So let me just take a look here. 2 times 4 is 8z. This one, the z's cancel and we get 12. This one, the 2's cancel. Yes, I think I made a little error here. This one, the 2's cancel, okay? The 2's cancel, right? And then we have a z from here and a 5. I think I looked at that the wrong way. So let's do this one more time. This is one reason why this may not work too well, because you have to be super careful. 2 times 4 is 8. Z. We've got a z here. Then on this one, we've got the z's that cancel. We've got 2 times 6, which is 12. Equals. This one, the 2's are going to cancel. This 2 is going to cancel with this 2. And we have z times 5 left. So that was my mistake. I apologize for that. So this is 5z. Won't take us very long to clean this up. And I'll double check it one more time. So this is 5z. So again, 2's cancel, z times 5, 5z. So we're going to subtract 12 from both sides. So let me get rid of this. The 8z will stay, and on this side, we are going to have 5z minus 12. Okay? That looks better. Yep, that looks better. Okay, so we want to solve for z. So let's move the 5. So when you are solving for, you've got a pair like this. You've got a variable. You want to pick the one with the smallest coefficient and move it. So the smallest coefficient between 8 and 5 is 5. So let's go ahead and do subtract 5 from both sides. Unless you really like to work with negative signs, which I'm not too much a fan of either, but sometimes we have to. Minus 5z from both sides. So over here, 8 minus 5 is 3z. Equals, these guys go, 5 minus 5 is 0 times z is still 0. And this is 5z. I don't want it to look like a 2 at all. It's 5z. So it's it's 3z. I was looking at that. It's 3z equals negative 12. And now we want to get the z by itself. So we divide both sides by 3. And if we divide both sides by 3, we're going to get 3 divided by 3 is z. And over here, we are going to have negative 12 divided by 3, which is negative 4. Any questions on that? And what do we have to check? We need to make sure that this negative 4 right here is not going to cause division by 0. We need to make sure whatever answer we get does not cause division by 0. So z is equal to negative 4. If we put negative 4 in for this z here, this entire denominator is going to be negative 4. This denominator is 2. So we have no division by 0 occurring. So we know that this right here, negative 4, is the answer. Z equals negative 4. Any questions on that? And let me go ahead and circle this just to be super clear that that's, or write it even like this. Our answer is z equals negative 4. Now, you may want to go about this in slightly different than I have, but you will definitely want to get the same answer. That's also a nice thing to try after class is to actually redo the problems and see if it makes sense to you. There. I think that's good. Any questions on that? So let's take a look at this one. And I'll turn that back on if I need it, so we can see it nice and big. first step, completely factor all denominators. This is 2v. 6 we can factor down. So when you're doing these problems, you want to factor your numbers into primes. 6 is 2 times 3. And then 3v, there's nothing we can do with that. You see 2 is prime, can't do anything with it. V can't do anything with. 6 is not prime, so we write it as 2 times 3. 3 is a prime number, which means its only factors are 1 in itself, the only nice factors anyway. And the v we can do nothing with. But the 6 you want to factor into 2. You definitely want to factor. You're going to make your problem a lot more complex if you don't factor. And confusing. So let's look here what we need to do. Find the least common denominator. That's probably the biggest step of all. Take the first denominator that you see and just copy it down. When you're finding the least common denominator, take the first denominator that you see and just copy it down. It's already going to be in factored form. You really want to make it in factored form. You want to factor your denominators. And that's step 1. Step 1 is to factor all denominators. So we did that, 2v, 6 is 2 times 3, then we have 3v. Step 2, multiply both sides by the LCD. Well, let's find the LCD first. Let's find the LCD. So LCD, short for least common denominator, you want to take the first denominator in factored form. This is already in factored form, so you just copy that down, 2v. Okay? Now, what you're really going to do, just to give yourself a visual, we're just going to copy down that first denominator in factored form. It is 2v. I'm putting it upstairs because we're going to multiply by our LCD. We're going to multiply both sides by our LCD. Now you can see that this 2 is going to cancel this 2. This v is going to cancel this v. I'm going to circle this because this is what we want to pay attention to here. Now what's going to happen is this equals, you're going to also be multiplying this by 2v. What cancels there? The 2's are going to cancel. You're just left with the 3. So you put the 3 here. Moving along, this term is also going to get multiplied by 2v. And so now we need to look at this denominator. So when we look at, and what did we put in there? At this step, we put in a 3, right? We put in a 3, and I forgot to put the 3 here. So let me put the 3 here. So we put the 3 there, there, and there. So each and every term is at this point going to be getting multiplied by 2v times 3. So the question now becomes, is this enough to get rid of everything in our denominator? In other words, our denominator has a 3 in it, right here. Has a 3 in it. We have a 3 up here, so that 3 is going to end up canceling this 3. It has a v in it. This v is going to end up canceling that v. So we do not need to put anything else in our LCD here. And I'll go over another problem with you when we, so you can see that even more clearly, so you can see it a second time, how we determine the LCD. So just real quickly, we copied down the first one, 2V. We then looked at that 2V to see if it would get rid of, what in that 2V would get rid of anything down here. There was a 2 there, but there wasn't a 3. So we put a 3. We then looked at that 2V times 3, 2 times V times 3 to see if it would get rid of this denominator. And you can see that it does. 3 divided by 3 is 1. So that gets rid of that. And the V divided by this V is 1. So it gets rid of that. So that's really how you go about this. We'll do another one before class ends today. So our LCD becomes 2V, 2 times V times 3, which is 2 times 3, which is 6V. So don't look at this. Don't look at this stuff in red over here. We don't need to do that, I think, because of what we just did. I have other ideas sometimes of what I want to say, but something came to me I thought would be more visual for you. So this LCD, we're going to multiply both sides by the LCD. On the left side, we have 7 over 2V. So we want to multiply by the LCD, which is 6V. Equals, what's on this side? 1 over 6 minus 8 over 3V. We want to multiply that by our LCD, which is 6V. So ignore what's on this side. We'll just go straight down. So what do we get over here? We want to cancel what we can't. So let's go ahead. What can we cancel here? We've got, let's do it this way. Let's do 6 to keep up with what I've got here. 6 times 7 is 42. We've got a V upstairs. And then we've got a 2V downstairs. And what can we do with that? V divided by V cancels. It's 1 really, times what's left is what's left. 42 divided by 2 is 21. So I just put that down here. Now the 6V gets distributed through here. So this is 6V times the first term, which is 1 over 6. And then minus. This is 6V, got a 6 and a V there, times 8 over 3V. 8 over 3V. So what kind of cancellation occurs there? Let's look at this first term. The 6's, this 6 cancels this 6, and we get 1. 6 divided by 6 is 1, times what's left is what's left, and what's left is V times 1, which is just V. Minus sign in the middle. Minus sign. Cancel this. You can take the 6 divided by 3. 6 divided by 3 is 2. So I put a little red 2 up here. And then V divided by V. So those V's go. So then we have 2 times 8 left. 2 times 8. And so we are now left with 21 on this side equals V minus 2 times 8 is 16. So we want to solve for V, and all we have to do is add 16 to both sides. And when we do that, we get 737 on this side equals V. And we want to go back up here and see if we put 37 in for each one of the V's, if it's going to cause division by 0, which it does not. So the answer is then V equals 37. Does anybody have any questions on this particular problem? So let's go on.
So you said you were gonna walk us through how to get the least common denominator.
I can't, can you repeat what you said? I didn't understand you.
You said you were gonna walk us on how to get the least common denominator.
Yes, yes, yes. Okay. For this problem that I just have on the screen, what's the least common denominator? Anybody want to take a guess on that one? What's the smallest
Would it
denominator?
be u minus 3?
Yes, yes, it's u minus 3 because that single u minus 3 can do double duty. That single u minus 3 will do double duty. So it turns out when you want to get the least common denominator, you copy down the first denominator in factored form. And that's in my notes. Completely factor all denominators, find the least common denominator. Can't factor this or this. No way to factor it.
So how would you factor it if the 2 had like a 7 under it? Like
Well,
as a
I think we're
fraction.
getting ahead of ourselves. So why don't we do this problem and then you can ask me, what if this, okay? So you're saying if that 2 had a 7 under it. Okay. I want to make sure I'm thinking about what I need to do by the end of class here. So yeah. First of all, what do you think?
After it's okay, like office hours.
Yeah, but let me just ask you your question really fast. So you're saying what would happen if you had a 7 here? Correct? Like you had a 7 downstairs here?
Yeah.
Okay. Before we put that 7 down there, though, let's look at the problem in its original form. So you want to factor your denominators, but we don't have any to factor in this problem. So not all steps are going to apply to all problems. So copy down the first denominator, and I would encourage you to put parentheses around your denominators like this. It helps me to remember to multiply denominators to, you know, if I had different denominators, it would help me, which I don't, but it helps me. So our first denominator is u minus 3. You just want to copy that down and start our LCD that way. So this is a little visual that I created just over here to show you what happens if you have just a single u minus 3 that you are using. So what's going to happen is that u minus 3, that single u minus 3, you're going to multiply it times this term, times this term, that single u minus 3, times this term. So that single u minus 3 is going to cancel that one out. That same single u minus 3 is going to cancel this one out. And then there's nothing, no visible denominator here. So the LCD is only u minus 3. So I'm thinking we should focus on these. How do you know which denominator? I think this isn't a big deal after you know what the LCD is, because the process is really the same for all of them once you have the LCD. Now you're saying, what if I put a 7 here, right? What do I need to do then? How does that change this LCD? We've got at this point, we have a single u minus 3. That single u minus 3 gets rid of this denominator, gets rid of this denominator. That u minus 3, does it get rid of the 7? Does a single u minus? No, so we have to then put a 7. Does that make sense?
Oh, okay. I see. Okay.
Yes.
Okay, cool. That's good. So I think I want to just spend the time on trying to help you come up with I'm just going to erase this so it doesn't cause any confusion, though.
Is the answer to this problem 4? U equals 4?
Yes, yes. See?
Perfect. Thank you.
You're welcome. Okay, So let's go on and let's see what we want to do here. So I think what I want to do here, first of all, there are some with no solutions here in ALEKS. What I got for my answer here was V equals -3. And I don't want to go through all of this right now, but V equals -3. I don't have the time. I wish I did. V equals -3. What happens with if we have V equals when V is -3? If I put -3 in here for V, we're going to get -3 plus 3, which is 0. We will have division by 0. And that was the only possibility we got. V equals -3. That's the only possibility we got. If you plug it in here, -3 plus 3 is 0, gives you division by 0, which is undefined. You're out of possibilities. So the answer, no solution. And right here, let's take a look at this. And let's just get started on it. I'm not going to do it all, but this is one where you definitely need to completely factor all the denominators. And I'll give you a hint. Chances are very high. You see this, the denominators, w squared minus 5w plus 6. I would put parentheses around these denominators, like this. Put parentheses around them. And it's very likely that these two together are going to multiply to give this. So w squared, at least I would try it, minus 2w minus 3w is minus 5w. And then negative times a negative is a positive. 3 times 2 is 6. So you know how this factors, right? It factors into w minus 3 times w minus 2. These guys multiply together, right? So you want to write this in factored form. So this is really 7 over w minus 2 times w minus 3. And I just copied the rest of this over. So the LCD is just, we take the first one here, in factored form, needs to be in factored form. So our LCD, we just take this, copy it down here. Now that LCD, I just wrote over all of these just to see what it would cancel, to see if it would cancel all of the denominators. So this cancels this one cancels this one cancels this, and this one cancels this. My denominators are gone. So my LCD is just w minus 2 times w minus 3. Does that make sense? And then you go through this whole problem, you get to the end, w equals 4. That's not going to cause you a problem. In this denominator, 4 minus 3 is 1, 4 minus 2 is 2. This has the same factors in it as these, so you've already checked it when you've checked these. Does that make sense? So that's what I want to say for today. So I want you to work on this particular objective. I think it should be pretty clear. You've got your strategy there. We went over a few of those. I think you've got a pretty good idea of what to do. Feel free to contact me. If you want to meet with me tomorrow during the day, I'm available. I don't teach classes on Fridays, so that's a good time to catch me. And I usually work on my classes on Fridays, so I don't mind being, I have that time devoted to NWAC anyway. So you're welcome to leave the conference, but let me make sure I've got everyone down for attendance because I need to do that for the college. Is Miriam here?
Yes, I'm here.
Cool. Yeah, I got you down. Stephanie here? Stephanie P.
Yes.
Stephanie P is here?
Is there two Stephanies?
Yes.
So which
Yes,
Stephanie?
You're Stephanie? Which
Well, we're
one?
both here.
Yes, okay, cool. I got both of you. I already had one of you down. And I tried to take attendance as people were entering. Sailor,
I'm here.
good. And Hayden. Is Hayden here?
I'm here.
Great. Okay, perfect attendance. That's great. So feel free to leave, but if you want to stick around, I can go over some more of this because I have office hours right now. So feel free to leave. Have a great weekend and reach out to me if you need any help. Let me know how you're doing on this objective.
Can you scroll down?
Can you speak again? I didn't hear you.
Can you scroll down a little?
Yes, absolutely.
Thank you. That's good.
Wait, when is this objective due?
This is due on Sunday.
Okay.
The objectives are due on Thursdays and Sundays. Wanted to space it out. And I make it the one during the week due on Thursdays because we meet Tuesday, Thursdays, and I don't want to just give you one day to do it. Do you see what I'm saying? Basically a day and a half to do it. We meet in the class, in the afternoon. So I wanted to make sure I did it that way.
Quick question. So in the comments, I commented my email for the participation points. Is it showing up?
Let me see. I think somebody is. Can you see it in the chat?
So I personally, in my chat, I can't see it.
Did you hit enter?
I did.
Okay, so let me just. I think another student is copying it. Are you copying? Is somebody copying down what's on the screen here?
No.
Okay, then I'll check the chat. I just want to make sure I've. Okay, so the meeting chat, and what is your name that you want me to?
For Alejandro, I see it.
Okay, you see it? Okay.
Yes, it's right above your response. 2 responses.
Oh,
above.
yeah. Okay, went up.
Yeah.
You were quicker than me.
Wait, what time are you available tomorrow for office hours? Because I don't understand this topic that well as the others.
Right. It's getting a little more difficult. It's starting to get more challenging, isn't it? Because it's not strictly a review. They're not review topics necessarily. So what time works for you?
Like this time, 12 to 1. Around that time.
12 to 1 p.m. tomorrow?
Yeah.
You want to meet?
Yes.
Okay. And what is your name?
Matthew.
Matthew?
Mm-hmm.
Okay. And this is the Tuesday, Thursday class. I'm writing this down. Yes, I'll meet with you and we'll just use the same link.
Okay.
And if anybody else wants to come at 12 to 1 tomorrow, we can do that.
All right. Thank you. Have a good day.
Yeah, you too.
Okay, yeah, I might sneak in tomorrow also, maybe if I have some time.
Or is there a different time that would work better for you?
No, it's just I have a bunch of homework right now from other classes, so.
I see. And so this is for, you would use the same class link as you're using now.
Okay, sounds perfect. Thanks, Ms. Bear. See you later.
Bye-bye.
Bye.
Anybody else have a question or a comment? You're welcome.
Do you mind going back to the screen where the problem was?
Yes, let me just see if anybody else needs to leave or wants to make an appointment with me. We got a couple students in the class. Okay.
I had a question.
Yes. Okay. So is it a quick question or should I do Alejandro spoke out first? So I feel like
It's a quick question. So I have a knowledge check coming up.
Mhm.
Do we, I know we're not supposed to use notes and everything. Whenever we're writing down the problems, are we turning in that work into you?
No, the knowledge checks are just the only time you're going to turn written work into me is for the first 7 questions on each test and the comprehensive final. So 4 times this semester.
Okay.
Does that answer your question?
Yes.
Okay. Do you have any other quick questions?
Are they graded, the knowledge checks?
They are not part of your grade in any way, shape, or form. They're
Okay.
just there to read at different intervals so that the Alex artificial intelligence software can determine your unique learning path to see what you need to learn. In other words, to see what you need to retain. Does that make sense?
Yes.
Okay. Okay.
Thank you.
That's good. Anything else?
No, that's it.
Okay. Well, have a nice weekend.
You too.
Bye. Okay, Alejandro, what do you want me to do?
Go back to the problem we were just working on.
Okay, this one. Where do you want me to start?
Yes, that's good. I was just finishing copying it down.
Okay. But if
yeah,
you want me to go over it with you, I will.
I think for the most part I understand it. You factored out the first denominator, got the least common factor, which was the W minus 2, and then the W minus 3. That would be the least common factor. And then you
Does
just
this
went
help?
ahead and multiplied the W minus 2, W minus 3 over both sides, canceling on out the first side, just leaving 7, canceling out the W minus 3 over the 1, then multiplying the 1, which would be itself, then getting the 5, distributing the 5 over the W minus 3, which would then lead to W minus plus 5W minus 15. And then
Oh, yeah.
you're adding the W minus 2 plus the 5W minus the 15. Just that thing. Okay, so 6 and then minus 15, 17.
Yes.
Yeah, and then plus 17 on both sides, then to try to get the W by itself.
That's really great that you can just talk like that about this. You're talking like you know what you're doing, honestly.
Yeah, it's I'm pretty good at math for the most part. So it's kind of, it's like, yeah, I'd rather do math than English, if that makes sense, you know.
Yeah, well, which one do you think I'd rather do?
Yeah. I had to take a guess.
I have a
Probably
daughter
math, huh?
that is so good on English. She scored sky high on her, she's in high school, on her PSAT in English. I'm like, I'm not like that. I'm
Yeah.
opposite. Total opposite.
Yeah. No, yeah, math. I like it. Math. It's always explanatory. It's sometimes complicated, but there's always an answer.
And don't forget to check this number in the
Yeah,
original.
the minus 4, just plug it back in. Make sure it doesn't equal 0.
Yeah, just plug it in. All you have to do is
So-
plug it into all you have to do is plug it into the denominators. But here you only have to plug it in here for W and here for W, because this right here is just W minus 3 times W minus 2.
Right.
And so you only have to plug it in here and here, because if it's
Okay.
not, if it doesn't give you 0 either here or here, it's not going to give you 0 over here.
Okay, so just as long as it doesn't give you 0 in the bottom, because you
Correct.
can't divide by 0.
You
Okay.
cannot divide by 0. That's
So
absolutely.
that, yes. So that is the only rule in this thing.
In terms of, yeah, so in terms of when you're not going to have a solution.
Okay.
When possibly you're not going to have a solution.
Yes. Okay. Okay, I think I kind of understand it. I'm gonna do the ALEC thing. I'm gonna finish the one assignment I have left for the thing due today, and then I'm gonna start on this week's. When is this due? On Sunday?
Yes. What about the assignment that's due tonight? Do you have anything you need me to go over with you on that? I have office hours anyways now, so you know I'm more than happy to help you.
Actually, maybe.
Okay.
I'm in the last little check, which I think is here. Let me check my notes.
Yeah, let me just let me make sure. Let me go ahead and pull up that assignment, okay?
Okay. Yeah, let me pull it up as well.
That'll be cool. And just think about it. Yeah, I've got the objectives, part 2, the second objective. Yeah.
Right.
And that's what yes, we've got some factoring and we've got exponents in that.
Let me.
But if you want me to go into Alex and do one for you, I can do that too. So it's up to you what you want me to do.
Hello.
Yes, I'm right here.
Sorry, I lost you for a little bit. My phone kind of disconnected. I'm trying to connect it to my PC.
That's okay. Take it.
Okay. Can you hear me?
Yes, I can.
Okay, perfect. Now you're on my Mac. Sorry, I had to drive to work, so
Oh, that's so
I do.
cool. We're going Mac to Mac.
Yeah. Usually what I do is when I have to come to work, I transfer you to my iPhone, and then from my iPhone, when I get to work, I transfer you back to my Mac.
I see.
So here, let me pull up Alec. And there on the last part, I think I understand it.
So let me make sure I'm not too far away from Alex here. So I'm gonna get into. Do you want me to? I'll be glad to do something in Alex because it may be more insightful to you to see it that way. It depends what you need.
Yes, I'm trying to see what it's called exactly.
Yeah, so I'm getting into Alex right now, so I'm.
So yes, I am in the last topic of the review. I finished 5 last night. So it is called using subtraction to factor polynomials.
Using subtraction to factor polynomials?
Uh-huh.
And
it says factor completely. So one of the questions is x squared. So parentheses x squared plus 8 close parentheses square that minus 5 open parentheses.
I know what we can do if you're willing to do it since.
Share screen on Mac?
Yeah, just a second. So let me just turn off the recording here.
Mm-hmm.
Yeah, and I'm going to. Do you have in your meeting that you're in? Do you have some icons across the top over to the right?
Yes.
Do you have one that's right next to the leave button that has a little upward pointing arrow? So the leave button's at the very end?
Yes.
If you click on that, you should be able to share your screen. So this upward, so maybe if I think, look at that, I see that. Oh, that's so cool. Thank you.
And you can also do Mac on Mac. If you have a Mac as well, and I have a Mac, you can actually use my computer, and I can vice versa. I can use your computer.
Wow, that's scary.
Yeah, but I mean, it asks you for like, hey, so and so's Mac is trying to access your Mac. Do you allow? And you just hit allow, and then you have to press a little access code. But yeah, it's pretty handy when like you're doing code or something, and you're asking a friend or whatever to like explain it, or a professor. You can handle that.
That's
but
cool. That come up on my computer for my daughter because she has a Mac too.
Mm-hmm.
Okay, I've got it. So let's take a look at this one. I'm going to go down to Word and do this one. I copied it down. So I'm going to go down to my desktop to do this. Yeah. So you want me, I'll need to share my screen to do it.
Yes.
So I'm going to share my screen.
Okay, so I'm going to stop sharing my screen.
Yes. Okay. So now I'll share my screen. How long have you been using Macs? A long
So
time?
I've been using Macs my whole career because my brother actually gave me his Mac. This is I just recently bought another Mac Pro.
Oh, so did I.
Yeah. So right now I just set it up and I don't know quite how to use it 100%. So I'm still using the old one right now. But this is the 2013 model or 12. He graduated grad school back in 2015 or 14. So he didn't need his computer anymore. So he let me use it. And now it got to the point where the battery on this one dies like crazy. Like it constantly has to be plugged in and it no longer updates because Apple is like that, you know? So
Well, I've
yeah.
got a 2017 Mac, and I can update it, but there's not enough space in it. The updates now are requiring so much space on your
Right.
computer. So
Yeah.
that's the problem. I just ordered a new Mac. It hasn't come yet. It should be here in sometime in the next few days, actually.
Which one did you get, the Pro or the Air?
The Air. It doesn't have. It's a true Air now. It doesn't have a fan in it or anything like that.
Yeah. Did you get the one with the M1 chip? That's their brand.
The Apple
Yes.
chip. I did.
Yes. That's good because it's gonna last you for a while until Apple comes out with something better, which they always do. And
Yes, they do.
they're like, hey, let's slow you down.
Right. I'm going to see if I can get a place here to do this. This is so much fun because we can really relate to each other. I'm just such a Mac girl. I discovered
Yeah.
them in 2010. I hardly have touched a Windows computer.
The only reason I use Windows is because of work. I work at Tyson, and we have a window process. We have a contract with Windows and HP, and that's the only reason I use Windows. But personally, I love doing Mac. Like Mac, I understand is so much better than Windows. Like Windows 10 is so complicated. It's so
No, and it does weird things because my husband uses one and it does such weird things. It doesn't make sense to me.
yes, the Mac is user friendly, in my opinion.
Yes, it is very user friendly and it's very much more secure too, I feel too, to be honest
Yes.
with you.
Mhm.
I'm looking for my markup tools here. I know they're here somewhere. Oh, draw. Okay, draw. Okay. So let's do this problem. So this is one where you want to make a U substitution.
Yes.
So the problem is, and I am so afraid to give up this Mac at all, and I'm not going to, because I can write on the trackpad on it with my finger. So that I really
Yes.
love. I don't
Yeah.
know if
You're gonna
having
have to buy which I went ahead and bought it when I purchased my Mac, literally like last week. It's called the Dock Station. And because the new Macs don't come with USB connects as like the older ones did. So the Dock Station is like $100. It's a little bit pricey, but it's worth it if you like using the mouse pad and the different keyboard instead of using the keyboard that it comes with it. Yeah, definitely. I recommend getting a Dock Station.
Oh, thank you. You know what, I have a friend that I've known for like 30, 40 years. I mean, seriously. And he recommended that.
Yes.
He recommended that I get an Apple Card.
Yeah.
That's what, and I did. Shouldn't be doing that. It's just, I don't know. I used to be a computer consultant for 5 years of my life. I love solving systems problems. Okay,
Really?
so we have this.
Yes.
So the first thing we're going to do is do a U substitution. So we're going to let U be equal to
X squared plus 8x.
x squared plus 8. Just what's in the parentheses here.
Oh, yes, plus 8. My bad.
No, it's okay. X squared plus 8. So that's going to allow us to take out what's inside here and here and replace it by just U.
Mm-hmm.
So we get U squared, because there's a squared on the outside here,
Right.
minus 5 u times u
Mhm.
plus 4. Like that.
Yes.
So we can factor that. So how would that factor?
So it has to multiply to 2 and add to give you -5, correct?
Multiply to give
I mean,
you,
to 4
yes, and
and
add,
to give you -5.
that is correct. So I just wanted to see how you tend to factor by asking that question. So this is like the multiplication column, and it has to multiply to give us +4
Mhm.
and add to give us
-5.
-5.
So I mean, we can do the whole tree, which I mean, 2 times 2 gives you 4, but it doesn't add up to give you -5. 1 times 4.
Correct.
1
So
-1 times -4.
So we
That
could do
adds up
this.
to give you -5, and that would give you +4.
So we have 4 times 1, but that's only going to give us +5. But if we change the signs on these, we get -4 times -1, which gives us, when we add them together, gives us -5. So these multiply to give us negative, 2 negatives make a positive. 4 times 1 is 4. And they add, -4 plus -1 is -5. Right?
Yes.
So now we know, since lucky us, we have leading coefficient 1. So we're going to put a u here. And then we'll put -4 in this one. And then we're going to put a u here. And we're going to put -1 in this one. Like that. And I just like to double check it. U squared -1u minus 4u is -5u plus 4. Good. Okay. So now the u has done its duty. It's done what we need it to.
Yes.
It helped us factor, basically. So we now need to go back to x's. So we're going to get u is x squared plus 8. So x squared plus 8 . And we can't forget about that -4. And then this one, x squared plus 8. And then -1 from this -1 right there. Now we want to clean those up. So this is x squared . 8 minus 4 is +4. And this other one, x squared . 8 minus 1 is 7, +7. That looks like that's the answer. I mean, some of them you have to, there's
Would that be the simplest form? Because on the last one, I left it like that, and it was like, oh, there's a simpler form to your answer.
Right. Well, that's when you, from what I've seen is you would have to have the difference of 2 squares to simplify it more. And we don't have difference here. We have sum.
Okay.
Can you enter this in and see if it gives you the correct answer? Because I don't see any way there's nothing we can do here. We don't have like a sum of 2, we've got a difference of 2 squares. We do not have a sum of 2 squares formula. And anyway, 7's a prime number, and there's no way to take the square root of that even. So
Right. Let me see if that takes them. Yes, that is correct.
Okay.
That is the simplest one.
So if you come up with the difference of two squares in both, then you have to go further. Like if you had x squared minus 9 times x squared minus 4, for example, then you would have to factor further. So if you had something like this, let me just, let's do x squared minus 1 times x squared minus 9. So if you got to this, let's say, because I've seen ones come up like this. Then you would have to go further
Yeah.
to be a 9. So this factors into x plus 1 times x minus 1. Does that make sense? Or do you want me to?
Yeah, that makes sense.
And this one factors into x plus 3 times x minus 3. Does that make sense?
Yes.
Yes. So then you would have to go further.
Yeah, I see that.
Now, if you saw something like this, though, let me get the running out of a little room here. So let me just, if you saw something like this, though.
So this was the previous question. Here, let me show you my camera.
Oh, yeah, just a second. Let me just finish this right here. So if you saw something like this, though,
Mm-hmm.
that's supposed to be a minus 3 there. And I need squares on these. Okay. I didn't put my square there, the right place. I need squares on it, though. Squares should go on the outside of the x. So if I did this, so I want to just point this out because I've also seen ones like that. If something comes up like this, this has to be a perfect square in order for you to use the difference of two squares. So 1's a perfect square because it's 1 times 1. And 9's a perfect square because it's 3 times 3. You see what I'm saying?
Yes.
But 6 is not a perfect square. And 3 is not a perfect square. So if you came up with something like that, you would just leave that. That would be your answer.
Mm-hmm.
Okay? Okay, so what do you want to show me?
Oh, it was just this one.
Okay, so let me come back up there. Oh gosh, I'm not sure I can read it like that.
Yeah, I'm not sure either. Oh my gosh.
Can you tell me which Alex one that is or something?
It was.
Or share your screen.
Can you go back on this? Can I go back and see which ones I'm working on?
Go ahead. So you mean is this another topic in this substitution in this same objective that's due tonight that you're talking about?
No, it's the same topic. It was just a different problem in which I got as the final answer.
Okay, can you read it to me then?
Yes. It was, so the original problem was x plus 5 squared.
X plus 5
squared.
On the outside?
Minus 2.
Minus 2, okay.
Parentheses x plus 5.
Okay.
Minus 63.
Minus 63. Now then I'll share my screen. I think it might cancel your sharing if I do that. I don't know how that works. Maybe we'll try it. Okay, so let me go back to Word. It looks like it's sharing my screen.
Mm-hmm.
So I want to get another one of these let me see if I can somehow I want to get another document here, a window. Give me another document. Let me see if I can. I know a file. Okay. I'm not a Word user because I don't typically use, but it's free at NWAC, and so I've tried it out. Let me see if I can find the window. How do I get another one? Let's see. I'm forgetting how to get another document here. Well, okay, I know what we'll do. So we're done with this, right?
Yes.
Should it? This one should erase pretty fast. Let me see. I'll have to make sure I know how to do that because I like to do that sometimes. Okay, at least we've got some space right now. So we'll, once I get this done. All right, so we've got this. X plus 5 squared. Tell me if it's not correct, okay? If I write something that's not correct.
Mm-hmm.
X plus 5. Oops. Somehow it got in the header. That's so funny.
Yeah.
New document. Now I remembered where to put. It's just so many. So, I mean, one thing about this, the way this style of teaching, there's just so many little things to remember about all these different softwares. Okay.
Yes.
So let's go with this. Okay. X. I need to get out one of these. If you don't like the color, let me know. X.
Oh, okay.
This is kind of some random color stuff. Plus 5 squared. Minus 2 times x plus 5.
Mm-hmm.
And then minus 63, correct?
Yes, correct. And for that, I got that was equivalent to x squared minus 16 and x squared minus 4.
Okay, so let me just work it out real fast. So our u is x plus 5. So this is really u squared minus 2u minus 63. Right? When we convert to u's.
Correct.
So now we're looking for two numbers that multiply together to give us, supposed to be a multiplication symbol here,
63.
okay. Negative 63.
Mm-hmm.
And add to give us negative 2.
Yes. So that I got negative 9 times 7.
Negative 9 times 7. So negative 9 times 7, 63. So that's negative 63. And then negative 9 plus 7 is negative 2. So then this would factor like this, u minus 9, u plus 7.
Yes.
So then we have to put our x plus 5s in.
Yeah.
So we would get x plus 5 minus 9, which would be minus 4, correct?
Mm-hmm.
And the other one would be x plus 5 plus 7, which would be plus 12. And there's just nothing to factor there anymore. Do you see what I'm saying? So that would be it. You agree with that?
Yes. I gave you the wrong problem. That's on me. I gave you totally the wrong problem. I got the same.
It's okay.
I was like, wait a minute, that is not right.
Okay. So I'll just get another document. Just
correct as
why
well.
don't you read it to me slowly, and I'll just write. I'll just write it up here.
I'm sorry, I can't read my own writing.
Okay.
It's actually going to be x squared minus 7.
X squared minus 7, like this.
Mm-hmm.
Okay.
Raised to the power of 2. Minus 6 times x squared minus 7.
Whoops. Let me just maybe give that to me. The curves are what's really hard to draw with my. Okay. There's a curve. So what do I have after that? Sorry.
X squared minus 7.
X squared minus 7. Oh, that should have known that, because I could have just copied what was inside the first one. Over 7, or minus 7 rather. And then what's
minus 27.
Okay, so I've got it all correct on the screen right now.
Yes.
Okay, so that's going to give us u.
So that's going to give us u squared minus 6u minus 27.
Yes.
And the factors for that I found were -9 and +3.
-9. Here, let me make sure I get my u in there. U minus 9, is that correct?
Yes.
And u plus 3?
+3. Mm-hmm.
Okay.
And then I went ahead and replaced the u with the x.
Okay, so let me just check that real fast.
Mhm.
So u squared minus 9u plus 3 is minus 6u minus 27. Okay, so then you would then you got
x squared minus 16.
So you got x squared minus 7, right?
Oh yeah, minus 7
9.
minus 9.
Okay, minus 7 minus 9. Okay, minus 7 minus 9 is minus
That's
16.
uh-huh.
Yes, this is the difference of two squares.
Oh, okay.
And then this one is x squared
It's -4.
minus 7 plus 3 is minus 4. Yeah, these are the difference of two squares. So you just have to factor them using the difference of two squares formula.
So that's the difference of two squares formula.
Yes. So like,
because so that I was like, okay, this is my answer. So I plugged that into Alec, and Alec were like, this can be simplified even more. And I was like, what? And it took me a while, and eventually I simplified it to 2x, x minus 2, x plus 2, and x minus 4, x plus 4.
Yes, that's exactly correct. And the way you know is because this has a very nice square root.
Yes.
And so does this.
So if those two numbers have a nice square root, then it can be factored out further, correct?
Well, you need to have minuses here.
Minuses as well?
Yes, you need to have minuses.
So say, hypothetical, if the minuses were plus, then
you couldn't do it.
You couldn't do it.
There's no sum of two squares formula.
Okay. Okay, so that's where I messed up on that one. Well, didn't really mess up, but I kind of got tripped up on that one.
Yeah, that's what I'm noticing. That is a rather challenging topic, to be honest with you, but it's good.
Yeah, it's because there's so many little steps that you mess up one step, or you try to speed up like in your head, and next thing you know, you just skip 2-3 steps. And,
right, but that's a good way to learn math on that. And learn what we need you to learn in here.
So what about if the u is equal to x squared minus 3z?
So are we talking about the same topic?
Yeah, same topic. So what if like the u is equal to x squared minus 3x? Like there's a 3 and an x.
Okay. So let's see. Let's just put the u. we'll take these guys out and see.
Yeah, because on this, I feel like I understand it. There's just little bitty things that I'm like, okay, like that right there, the sum of two squares. That kind of tripped me up, and I was like, oh, whoa, hold up. Let's wait a minute here. But
Let me make sure. Okay. So we want x squared minus 3x in here. X squared minus 3x in here.
uh-huh.
Do you want me to do this problem? Or do you want to change the coefficients in front in any way?
If you want, yeah, we can change the 6 to a 2 and the 27 to an 8.
Okay, so let me do that. So the 6 becomes so that one becomes a 2, correct?
Mm-hmm.
And I'm going to get rid of this one on here because I've got that. Okay. So so I have a 6 here, right?
A 2.
A 2, okay. And then over here?
An 8.
An 8, okay. Okay, so we know what this is, x squared minus 3x, x squared minus 3. Okay, so we know that's going to become this 6 goes. This goes. Okay, so then this would be a 2, and this would be an 8.
Right.
And this, I probably should take these out just in case. Okay. So now we're looking for two numbers that multiply to give us -8 and add to give us -2. So that sounds like it would be 4 and 2.
Yes, 4 and 2.
So we would have 4 and 2, and then we're going to have to figure out the signs. So let me just put 4 here.
So it'll be -4 and +2.
So -4 plus 2 is -2, and then -8. Okay.
I mean, you substitute the u for the x value, correct?
I'm just trying to figure out the best that I should take care of here. I guess I'll just do this. Okay. So now we're going to have x squared minus 3x that x squared comes from here, minus 3x minus 4. Okay. And over here, we are going to have x squared minus 3x plus 2. Does that make sense?
Yes.
Okay. So these might continue to factor, but they're trinomials. So we're looking for two numbers that multiply to give us -4 that add to give us -3.
So that would be 2. 1 and 4.
Okay, so 4.
So it would be -4 times +1.
Okay. -3. So can you tell me those again? I was going to write this out. Yeah, it's kind of.
Yeah. It will be -4 times +1.
Okay. That multiplies to give -4, adds to give -3.
Mm-hmm.
So this would then be x minus 4 times x plus 1. That first one here, this one.
Mm-hmm.
And then we have this one here, which we want two numbers that multiply to give 2, that add to give us -3. They should be what?
-1 times -2.
Correct. So this would be x negative -1 x minus 2. Okay,
Correct.
does that look good?
Yes, ma'am. And that would be your final answer, correct?
Absolutely. I can't do anything. This is definitely the answer here. I don't see anything wrong with that.
Yeah, neither do I. So essentially, when you get to that, you just continue factoring.
Yeah, when you get to like this part, you have to ask yourselves, can you factor further? So these trinomials, you want to check to make sure you either want to factor them or you want to make sure they don't factor, and then you want to look out for the difference of two squares too, if we're talking about this particular topic.
Awesome. All right. Yeah, I think I understand that a lot better.
You certainly seem to understand quite well. I'm impressed. I'm proud of you. You seem like you're a hard worker too. Like
Yeah.
Determined.
Yeah, I definitely do not let things beat me.
I don't either usually.
Yeah.
I don't. I'm like, I'm just gonna do it.
Yeah. I'm trying to look back at my notes to see if I had any questions. I usually take notes to like things I start things that I don't quite understand. Just
right,
to not,
you're right.
Yeah, just to, I mean, I know there's no dumb question. I'm sure that other students had the same question I had, but I usually just start and go, because in the past I've had professors that just love to teach, right? And then if you don't quite understand something, just go to their office hours. And I got to the habit to like just start things I don't understand, continue, start thing I don't understand, and then later on be like, hey, I started these things in this lecture, so and so. So
I'm just checking my office hours here. Just a minute. So on Tuesday, we meet on Monday and Wednesdays, and so I have office hours on Monday and Wednesdays from. Oh, wait a second. No, this is Thursday. This is Thursday class. I'm like, I can't think of my days are mixed up. This is Tuesday, Thursday. Yeah. So we've got.
don't worry, that was me yesterday. I thought yesterday was Thursday, and because I saw the notification on my phone ring like Teams meeting in progress, and I'm like, did I really just miss class? Like I was like, I could have swore today was Wednesday. But
Yeah, technically I don't have office hours today, but I have no problem meeting with you after class or any students at this class. And the same with the one. Wait a second, let me look. Oh, I get you. I got to look at this the right way. So Tuesday, my office hours, I had to create this document for the math department, and I had to figure out how it's supposed to read now. Tuesday, office hours from 2 to 3, which is what we're in right now. And Thursdays, office hours from 2 to 3. So
yes.
I try to do it around my classes, thinking that not everybody, there's no time that's going to be perfect for everybody. And I thought I would, if I did it around my classes. So we both Tuesdays and Thursdays, I've got office hours right after class. So that should help, if you can make it, you're welcome to come to office hours.
Right.
And I wanted to do it so that the links wouldn't, the links, they are to keep track of these links for these remote classes. It's quite challenging. So I don't want to make it any harder. And I want students, if they could just stay in the Teams meeting, and that's great.
Yeah. No, definitely the way you do it is okay. Some professors do it differently. That's why it took me kind of like to really realize. I was like, is today class? I even had to check your syllabus. I was like, there's no way like there's class today. It's like it's only a 2-day class a week, so I was like, a Wednesday class. And then because I was seeing the chat go crazy of like, oh, Miss, we
Oh
can't.
yes, I see. It is confusing. So I'll be sure to talk about that. I think the best way is to check Canvas.
Yes, that's what I did. And even then, I had a text. We have a chat yesterday. Somebody started a group meet. That's an application that I'm new to as well. But they were talking about study buddies, and I was like, might as well join it. In the chat in the very, very top, from yesterday, it was sent at 2:17 p.m. Somebody started a group meet, which is basically like a Teams. It's like another platform you can communicate with people. And so far, there's like 5 or 6 people in that group meet in our class in our Tuesday, Thursday. So that's like the class if there's 11 people in the class.
So where do they meet?
There's the link. The link is right there in the chat. If you want to scroll up, you're gonna see like a little blue icon with like a smiley face. A little bit more up.
Oh, it's the one from yesterday, I think. From yesterday.
Yes,
This.
right there. That.
Yes.
That is for the Tuesday, Thursday class.
Yeah. That. Did somebody put that in here today?
Yesterday.
Yeah, it was yesterday. It was some for my Monday, Wednesday class that put it in there.
Oh, I thought it was Tuesday, Thursday. I even texted her. I was like, "Is this Tuesday, Thursday?" She's like, "Yeah." I was like, oh, "Okay, cool."
You know what? Let me just say, it doesn't matter which one because I cover the same material in both classes. They are a bit off, though. That's the problem sometimes because of Martin Luther King Day, for example.
Yeah, look, I texted her. Hey, is this for the Tuesday, Thursday, 12 to 1:50, right? And she was like, yes, but nobody joined because I was like pretty fast to join. I was like, it's okay. I'm sure people would join later, and which they did. There's 5 other members in the group.
That's interesting because that class only has 10 people in it, and so they're really that's fabulous because I'm like it's so important, to tell. So when I was in graduate school,
Mm-hmm.
I studied with this man. I ended up marrying him. I was his study buddy. We were study buddies.
Yeah. My brother, he basically did the same thing you did. When he was in grad school, he always explains grad school that it's basically you do a lot of readings, then you get together as a group, and like it's just a discussion. Like, hey, what you think about this and that, and you just talk, and you do everything like out of class, and basically the only reason you're in school in the university is either to teach the class that the professor assigns you, or to be in a discussion group, right? And anything out of that, you get study buddies. You go to the local bar, the local lounge. You go.
Taco Bell. That's what we did.
Yeah, exactly. Anywhere you can just meet up and has Wi-Fi.
Right. So I'm like older. We didn't have Wi-Fi in those days. So.
Yeah.
But I had to learn, and I love technology. So that's what I mean. I don't let anything hold me back. I don't say, hey, I didn't learn it, so I'm not going to use it. Yeah. Well, it's a pleasure to work with you, and I hope we can work together some more.
Yeah, for sure. I'll just keep starting. I did encounter one thing I did start today. Multiplying the imaginary number, the I. So I'm pretty good on the division side. Now on the multiplying side, the rule on that is if it's like I squared, that equals -1. Can you show me some examples of that?
So let's go back to what we talked about today.
Mhm.
Or we'll have to go into. So let's go back here. Oh, this is the one we did before. Okay. Okay, so let's go back. And so those are the two, and I'm sharing my screen, right? I just want to make sure. Am I sharing my screen? Can you see
Yes.
it?
I can.
Okay. So here are the rules regarding I for right now. Square root of -1 is I.
Mhm.
If you square this side, you're just going to get, well, I guess we would, you can just learn this rule here. And then you can square this side and get I squared, square this side and just get -1. Do you see what I'm saying?
Yes.
Because it's less to memorize. And the less you have to learn, the better. Okay. So if we go to this one, this was the square root.
Yes.
Okay. Do you understand this one where you have to distribute the -I through?
Yes, for the most part, yes.
So do you have any questions? And if so, can you tell me which step?
It's basically just distributing the I, just treat the I as a number.
Yes, so it's
as a
not
variable.
technically a number, that is correct.
Yeah, like in imaginary.
So this would be
negative I into 3. Negative times the negative is a positive, so positive 3I. And then turn the 5 into negative I, and then I and I.
So you really just
I and the other I with the 5 get together, then that turns into I squared, correct?
yes, because this is I times I, really.
Yes, it's I times I, and that's I squared.
Yes.
That is -1.
Yes. And it's 5 times I squared, so it has to be 5 times -1. Sometimes students think it's subtraction if they don't put the parentheses on.
I'm jotting this down really quick.
Okay.
Again. Oh, okay, I see. And then you multiply the -1 and the -5, that gives you +5. I was like, where'd you get that positive? Okay, I see.
Good.
I see now. Yes.
So are you ready to go to the next one?
So your final answer is 5 plus 3I, correct?
Yes, it's just a standard operating procedure to put the I term last.
Oh, okay. Yeah, we can go to the next one. Here, this is what I starred.
Okay.
So if you don't mind, can you kind of explain it again?
Yeah, absolutely. Okay. So I want to write it down here so we can take a look at it. So this is -1 plus 5I times it's like, sorry about that. It's sometimes I don't get the angle right.
Yeah, it's a little hard.
It is with the curves. They are really hard. The curved letters too. And then -5 I'm going to make sure it's down here next to what we're doing. -5 plus 2I. So, just for a moment, just think of this as just as two factors multiplied together. And you want to multiply them together, which means you've got 2 terms in here because terms are added.
Right.
You've got 2 terms in here. Terms are added. Adding a negative is really means you have terms too, to be honest with you. So subtraction you can consider as terms in a sense. So we've got these 2 terms. And there's 2 terms in each. Terms are added. So we have this term, -1, plus the term 5i. Here we have -5 plus that -5 is a term plus the term 2i. So we've got 2 terms in here, 2 terms in here. That's when you have 2 terms times 2 terms, we can FOIL. So this is going to work just like you're used to FOILing. The only thing we have to keep in mind is that I squared is what? I squared is a -1. That's the only thing we have to keep in mind. Can you hear me?
Yes.
Okay.
Sorry,
Okay.
that's my radio. Don't worry about that.
That's okay. I just wanted to make sure. So
yeah.
we want to FOIL. So it's first, outer, inner, last.
Yes.
So in the first 2, we have negative times negative, which is positive. 1 times 5 is 5.
5.
The outer 2 is -1 and 2i. So it's negative times a positive, which is a negative. And we have 1 times 2i. 1's the multiplicative identity, so we just have 2i. Oops.
Yeah.
Okay. The inner 2, that's these guys. Plus times negative. Negative. 5 times 5, 25. Then we have this I. Okay, this I from here. Right there. That makes sense?
Yes.
Then the last, this one, positive times positive is positive. 5 times 2 is 10. I times I is I squared.
Yes.
I squared is -1. So what we have here is we really have over here, we've got 10, it's a positive 10, times -1. Like that, which is -10.
Yes.
So now we want to combine like terms. So the first thing we can combine is just the numbers. We have 5 plus a -10. So that's 5 minus 10, which is -5.
Correct.
And then here, these guys are like right here because they both have an I in them. So we consider them like terms.
Yes.
I is not a variable. So in order to have like terms, you have to have the same variables to the same exponents, basically. But we just consider the i's to be like here. Does that make sense? So we have -2 of them and -25 more. That's a -27 of what? I. Right? Does that make sense?
Yes. Yes,
And
that
that's
makes
the
sense.
answer.
That makes sense. So just take the natural, normal procedure. Just remember basically the I rules.
That's correct. That is
Okay.
absolutely correct.
Yeah. So it's just like normal. It's factoring.
Right. The only thing you have to remember is the I rules. That's correct.
Okay. Yeah, because I mean, if you were to forget that the I is -1, then you won't come out with -5. You'll
That's
come out
why I
with
wanted the
15.
students to copy that down.
Yeah. That's
Yeah.
that's good. That's good. Yeah, because that could change your whole problem.
Yes,
But-
it can.
Okay.
Okay.
I think that's it for now. That's pretty good. Thank you for the hour of tutoring.
Oh, no problem.
Did not mean to keep you that long.
No, it's okay. Remember, somebody's coming in tomorrow from 12 to 1. I don't know if you're available, but if you have any more questions and you're available, you're welcome to come and use the same link as you use for class.
Yes, yes. Yeah, if I have time, I'll drop by for sure.
Okay.
I'm gonna work on the ALEC program tonight. That way, if I can get any questions, I'll just jot them down and ask you tomorrow.
That sounds great.
And that ALEC thing, I think it's due on Sunday. It says.
Yes.
Yeah, due on
Yes.
Sunday.
Yes.
All right.
All right. It was so nice to work with
Can
you.
we work ahead?
Absolutely.
We can.
And work ahead.
Okay. Okay. I was just wondering if we had to like stay with the class or.
You don't.
Okay.
You don't. And I mean, coming to class, remote class will still, even if you've worked ahead, it'll make it will be good for retention, long-term retention.
Yeah. Okay. All right. Thank you for your help. Thank you for guiding me through it one more time. And
No,
I get
it's
it.
fun.
Yeah.
I enjoy working with students that want to, I really do. I miss it. I used to, my classes, I used to give the students about 25, 30 minutes of lab time when I was on campus and go around and help them. Can't really do it. There's just no way to emulate that in this environment.
Yeah, right.
Yes.
Right. It's hard nowadays.
Yes.
Hopefully we're back to normal next semester or next year.
Well, I'm not sure about the fall. I know summer, my classes are online or remote. I don't know about the fall. It just depends on how fast people, they can get enough people vaccinated.
Yeah, for sure. In the summer, actually, quick question. So I'm planning on taking some summer courses. I don't know exactly which courses I'm gonna take this summer, but it's probably gonna be a math course as well. That is gonna be remote, or is that gonna be on campus? Because right now I only have one class on campus. That's my biology class. It's the lab. We have to go 1 day a week on campus.
Yes, it's so hard to do labs virtually.
Yeah, it's difficult right now. My class, my professor was saying it's just on that borderline. Apparently, you can't have if you have more than like 15 students or 18 students. I forgot what the number was. You have to split up 2 days. So I go on Tuesdays, and then the group B goes on Thursdays, and then vice versa. We alternate labs. They do one lab, we do it remote. Then we do one lab, they do it remote.
Right. I've
And-
heard all about this because we have math and science division meetings. Yeah, I understand. It's really tough. Right now,
tough. I'm not a fan of biology, and that definitely does make it harder. But yeah, I do not like that one bit. That I really prefer it to be back like it used to be, just
me
in
too.
class.
I do too, but it's just not I don't know. It's too dangerous out there, I guess, is what I want to say.
Yeah,
So,
yeah.
and they just said in the state of Arkansas that teachers could get vaccinated, but the problem is the logistics of making that happen.
Yes, and it's my biology professor. He got vaccinated, but he said he had to wake up at like 4 or 5 in the morning to go get vaccinated, and there's like crazy wait periods on the vaccine, and there's only 2 vaccines here in Rogers or Bensonville that offers that vaccine. To two different facilities, right?
Right, but since I'm remote all semester, I put my name in a drugstore chain in Northwest Arkansas. They have several locations, and it's an appointment. So I'm just gonna hope that works out pretty.
That's what he was saying. He put his name in a thingy, and I guess his name got called, but he had to go like super early in the morning, and he got lucky. He said because there was another drugstore that the wait on the line was already like 11,000 people signed up for it. I'm like, that is crazy.
I have no idea how many the people have signed up for this place, but they do have several locations. They've got one in Prairie Grove, one in Fayetteville, one in, they don't really have a Bentonville location, although they are affiliated with Northwest Hospital, but they're not doing it. There's a couple others too. So I'm hoping that works out pretty well. And I've got, I'm teaching remote or online during summer only. And in the fall, I don't know what's going to happen. I really have no idea, because it just depends what percentage of the population gets vaccinated, basically. And the college is really wrestling with what to do in the fall.
Huh. So do you think that when we go back to on the fall, you think we'll have to show that we're vaccinated before we can be admitted?
I'm not sure what they're going to do with that. What they're going to do about requiring, I don't know what they're going to do about K-12 or the college regarding that.
Right. Because I know, like in certain public schools, if you don't have your vaccines up to date,
correct,
they can select to have you remote or just drop you in general.
But you know what? They haven't done with the vaccines. They haven't done any real large clinical trials on children yet. So they can't really, the K-12. They can't vaccinate them yet because they have to do those clinical trials first, and I don't think they've even really started those. So the only ones they can do are adults. The only ones they've done clinical trials on are adults. I think there are a few teenagers that they've done in some of them, but not enough where I would feel comfortable having my teenager get a vaccine. So
yes,
there's a lot that's got to happen here. So I guess I don't know. I'm hoping it somehow, some way it works by the fall, but I'm not sure. I think there's a lot of pieces and parts that have to come together for that.
Yeah, there's a lot of logistics in it too, as well. I mean, then you also have to think the people that are against vaccines in general.
Oh yes, and there are quite a few of them in Arkansas. There are a lot of
infringing their freedoms in a way.
Well,
but yet again, I mean, is a community college considered its own entity? Isn't it considered like government?
Yeah, it's the Arkansas.
It would be like going to like John Brown University, right? Like in John Brown.
It's just like University of Arkansas. I mean, we're the Arkansas Department of Higher Ed. We answer our community college answers to them.
Mm-hmm.
So they're over us. I mean, they dictate how our performance reviews are done and all kinds of things. So I don't know what they're going to decide here. I know how I feel about it, but I can't.
You can't make other people feel the same way.
No. And I don't believe any of this should have. I don't believe any of this should have become political, but unfortunately, it has.
Yeah.
So I guess that's what I want to say. I'll leave it at that.
Yeah, I'm with you on that. I'm 100% on you. I mean, that to me is like its own thing. It should be like its own thing. Like, hey, we have a freaking pandemic out there.
Yes, absolutely.
How do we make something that is literally killing people and putting other people's life at risk into if you support vaccinations, then you're not 100% with that party. You know what I mean? Whatever party you believe in or whatever. But to me, I'm with you. How did it become a political issue when it shouldn't have even got there in the first place?
Well, I'm more like, I agree with you. And I'm more like a diplomat. I have voted both ways in my lifetime, both sides of the aisle. I'm not neither. I have never declared a party in my life. So, I mean, my grandfather worked for the United Nations. And so, I guess maybe he rubbed off on me or something, but I just don't. I love all people all over the world, no matter your skin color or your race, whatever it is. I've always been like that.
Yeah, I'm with you. Both parties, they have good arguments on each topic. I don't understand people that can actually like just identify to one topic. To me, it's like, well, you're completely just like closing out your mind to endless possibilities if you just say, yes, I believe in this and only this.
Right.
I respect everybody's beliefs, but I'm like, you gotta at least hear the other person out. You know, you just can't completely say no, you're wrong because I'm right.
And when you're saying hear them out, it's well, you know, my idea of hearing them out is you both sit down and you hear each other out, and if you have questions, you answer them, and do it in a respectful way.
Right.
Like you sit down and have a cup of tea or something together or something, like you're
Yes.
buddies, but you just
I
might
mean,
disagree.
to me, when I watch,
Every-
I stop watching the news because every time I watch the news, no matter what kind of news, I guess they make it such a huge deal. And like to me, right now, when I see Nancy Pelosi and Mitch McConnell like talk about each other and like refer to each other like low key, to me it seems like I'm watching like 5-year-old little kids talk about like, no, I'm gonna do this because you're doing this. You know, I'm like, work together. Like everybody that has a high chair in our government system should be responsible enough and mature enough to say, hey, you know what, let's get together, let's work on this. We all have one goal. What is that goal? To make this country great, to help the people in this country. That is the same goal. You know,
right. We
regardless
have
of
so many issues in this country right now that they shouldn't be political at all.
yeah.
I mean, so many.
It's crazy right now. These are definitely like my one of my professors said these are historic times that we're living. For sure. It really reminds you of back in the day of how history repeats itself and how like right now we look at the things going on and it's like the 1960s, 70s, and 80s. And
But I was alive back then, and I don't remember it being that bad. But you know, I was young then, so I probably didn't have the same, you know, way of processing what went on as I do now.
right. Yeah, probably. But yeah, I mean, I'm with you. Even then, right now, it seems like, holy moly, what's going on?
I know. I know. Yes. Well, this has been a very interesting conversation.
Yes, it
Oh,
has.
yeah.
Thank you. I'll definitely try to tune in tomorrow if I have any questions. I'm gonna work on that like later tonight when I get off of work. Um, but yeah, I'll work on the Alec, jot down any questions I have, and I'll try to tune in tomorrow if I have time.
Okay.
If not, I guess I can email you if I had any
Yes,
questions.
that's correct.
Yeah.
Okay.
Okay, thank you.
You're welcome.
You have a
I'll
good day.
see you soon.
See you
Bye.
next class.